Welcome to today's Explainer. We're jumping right in today because if you've ever wondered why an AI model looks incredible in the lab but completely falls apart the second it hits the real world, well, you're in the right place. We're unpacking the single biggest trap in machine learning, generalization, or more accurately, the failure to generalize. To wrap our heads around this, let's think about a situation we've probably all seen before.
Okay, let's dive into this. Imagine a student who memorizes every answer to last year's practice exam word for word and then completely fails to real test because the questions were different. We all know someone who did this, right? They didn't actually learn the subject, they literally just memorized the answer key. Well, in machine learning, this exact same failure happens all the time.
So the crucial point is, we call this phenomenon overfitting. The entire goal of training a model is for it to work on brand new data. But if a model is just way too powerful and trained too hard on a limited dataset, it stops learning those broad, useful patterns. Instead, it memorizes the specific quirks, the noise, the totally random flukes of its training data. And since those specific quirks won't ever repeat in the real world, the model simply shatters upon impact with new information.
Catching a model cheating like this requires strict discipline. You literally never let the network see all your data during the training phase. Instead, you split it. You have your training set, which is what the model actually studies, and a locked-away test set. That test set is filled with fresh questions the model never sees until the very end. It acts as a true, unbiased final exam.
And this brilliantly illustrates what happens when we administer that final exam to an overfitted model. The results are glaring. Imagine a model scoring a near-perfect 99% on its training data, but absolutely bombing with a 60% on the test data. That massive gap? That is the smoking gun. It perfectly proves the model didn't understand the concepts at all. It just memorized the practice questions.
Once you spot that gap, you can mount a real defense. Engineers rely on 3 specific tools to fight overfitting: regularization, dropout, and injecting more data. Let's break down exactly how these fortify a model.
First up, regularization. Think of this as a gentle way to keep the model in check. By penalizing the network when its internal math gets overly complex, we firmly nudge it towards simpler, broader explanations. It entirely prevents the model from twisting itself into knots just to perfectly match random noise.
Now, what's really interesting here is the second tool, dropout. This is a fascinating technique. During training, the system randomly switches off some of its own neurons on every single pass. I know, it sounds totally counterintuitive to turn off parts of the brain you're training, but this forces the model to stop leaning on any single memorized detail or specific pathway, making the overall network highly resilient.
But despite those clever tricks, what's the ultimate solution? The most reliable cure, hands down, is simply feeding the model more and more varied training data. If a model sees a massive, incredibly diverse set of examples, it becomes mathematically impossible to memorize all the tiny quirks. It has no choice but to learn the actual underlying rules.
Which brings us to the core mindset you need to carry away from this explainer today. In machine learning, a perfect score on the practice test is not good news. It's a warning sign. The goal was never to ace the material you've already seen. The entire purpose is to handle the unknown. A memorizing model looks incredibly impressive right up until the precise moment it meets the real world.
So the next time you see an AI project boasting a flawless accuracy rate on its training data, step back and ask yourself, will that model actually survive the only exam that counts? Or did it just memorize the answer key? Keep learning, stay curious, and I'll see you in our next explainer.